All right, let's talk about something that can be your absolute best friend or your worst enemy when it comes to test automation inheritance. We're going to break down how to build Java Selenium frameworks that don't just work today, but are also strong, easy to maintain, and ready to grow with your project. So let me ask you something, and be honest. Have you ever inherited a test suite that was so tangled up, so fragile, that you were literally afraid to even touch it? You know, that project where you make one tiny change over here and a whole bunch of stuff breaks way over there. Yeah, if that sounds familiar, you are definitely not alone. The big question is, how do we stop building these houses of cards? And you know what's crazy? The culprit is often hiding in plain sight. It's this powerful concept from programming that we all learn about called inheritance. When you use it the right way, oh man, it's a total game changer. But when you get it wrong, it creates a rigid, brittle code base that is an absolute nightmare to deal with. Okay, let's get into it. Before we can really wrestle with inheritance, we all need to be speaking the same language. So let's just do a super quick tour of the main types of test frameworks you'll bump into out there in the Java Selenium world. So as you can see, there are a whole bunch of different flavors. You've got everything from data-driven to BDD, and each one has its own special purpose. But for our conversation today about inheritance, the one we need to zoom in on, the one that really matters, is the Page Object Model, or POM. Why? Because it's the foundation where these design choices can either make you a hero or cause a lot of pain. So let's talk about how to do this the right way. The clean, the effective, the modern way to use inheritance is to combine a simple base class with that page object model we just mentioned. This is the secret sauce. It gives you all the benefits of reusing code without painting yourself into a corner. First things first, what even is a base class? Think of it as the foundation for your house. It's one single focus class that handles all the boring, repetitive stuff. Like firing up a browser before a test starts and shutting it down when it's over. The whole point is to write that code one time and then reuse it everywhere. It's that simple. So how does this work in practice? Well, step one, we create our base test class. Inside, we use these neat little annotations, at before method and at after method. Think of them as instructions. At before method tells your code, hey, before you run any test, do this setup stuff. Then, after the test is done, at after method comes in and says, okay, time to clean up. All that boilerplate logic gets tucked away in one place. And here's where the magic happens. Step two, you've got your actual test class, maybe a login test. All you do is add one little keyword, extends. So you write login test extends base test, and boom, instantly, your login est gets all of that browser setup and teardown logic for free. No copying, no pasting. It's clean, it's simple, and it's incredibly powerful. The payoff for doing this is immediate, and it is huge. Your test classes get so much cleaner because now they can focus on just one thing, the actual test logic. You've wiped out a ton of duplicate code, which makes your project way easier to maintain. And maybe best of all, this structure scales beautifully. It works just as well for 10 tests as it does for 1,000. Okay, but knowing the right thing to do is only half the battle. If you really want to master this, you have to know what not to do. So now we're going to flip the script and look at the dark side, the common inheritance traps and anti-patterns that you absolutely have to avoid. All right, red alert, people. Consider this your official warning. These are the exact design mistakes and frankly outdated practices that lead to those rigid, impossible to debug frameworks we talked about. If you see these patterns in a project, that is a major red flag. Now, the really crucial thing here is to understand why these are such bad ideas. For example, inheriting directly from WebDriver. At first glance, it might seem convenient, but what you're actually doing is handcuffing your code to that one specific implementation. We call this tight coupling, and it means if you ever want to change something, anything, you're looking at a massive rewrite. You've built yourself into a corner that's guaranteed to cause problems down the road. All right. So this brings us to the modern way of thinking about all this. See, the software world has been slowly but surely moving away from relying too heavily on inheritance. Instead, the focus has shifted to a much more flexible and powerful pattern called composition. Let's break down what that really means. The classic way to think about this is a versus has a. Inheritance creates an is a relationship. A login test is a type of base test. It's a strict top-down hierarchy, kind of like a family tree. But composition creates a has-a relationship. A test class has a helper object that it can use. It's way more flexible. It's the difference between being a single Lego piece and having a whole box of Legos to build whatever you want. So, what does this all mean for you today? Well, here are the takeaways. First, definitely use that base test class, but keep it focused, only for setup and teardown. Second, always prefer composition over deep inheritance. Make it your default choice. Third, stick with the page object model. It's still a fantastic pattern. And hey, if you want to get ahead of the curve, start looking into something called dependency injection. It's just a fancy term for a pattern that gives you the absolute ultimate level of flexibility. All right, let's put this all together. To make this crystal clear, let's just do a direct side-by-side comparison of the old broken way versus the new recommended way. This is the cheat sheet for your next project. Seriously, if you're going to screenshot one thing, this is it. The old way was all about these deep, complex inheritance chains. The new recommended way? Use a single, lean, base test, keep your class structure flat, and use composition to plug your page objects together. It's the difference between a rigid building that will crack under pressure and a flexible, modular system that can adapt to change. So there you have it. The choice between a brittle, high-maintenance framework that everybody hates working on and a resilient, scalable one that everyone loves, it really comes down to these fundamental design choices. So the only question left to ask is, which kind of framework are you going to build next?